All right, let's take a look at this. Here we have the square root of 40, x cubed y. So first thing, let's break the 40 down using the birthday cake method. So we start with 2. 2 goes into 40 20 times, and we just keep repeating that. So we're just dividing that 2 into the inside. 2 goes into 10 5 times. And 5 goes into itself 1 time. When we get to the 1, that means we're done. And so what we do is we take these factors and we rewrite them. So this is 2 times 2 times 2 times 5. So 4, 8. 8 times 5 is 40. Now let's take the x cubed and expand it. So x cubed means there's 3 of them. And finally we have 1y. So all this exists underneath the square root. And so since there's no number written here, that means the index is 2. So whenever something appears twice, we circle it. And as soon as we circle it, we write it once on the outside. So I can't circle that 2, I can't circle the 5, I can circle 2 x's, and I write it once on the outside. And there's nothing else that repeats. So that means the inside, now we can multiply these. 2 times 5 is 10. And there's only one x and there's only one y. And so that would be my answer here. We're going to do the same thing over here with the 27. Two can't go into it, so let's do 3. 3 goes in 9 times. 3 goes into 9 3 times. 3 goes into itself once. And so that means underneath here we're going to write 3 3s. And because I don't have a lot of room, I'm going to take the x to the 5th and write it underneath 5 times. And then the y, I'll write underneath. So I'm going to do one big radical. And here the index is 3. So now I'm looking for groups of 3. So I have one group of 3 here. So I circle it. That goes on the outside. I have one group of x's here. Goes on the outside. And I have one group of y's here. So now everything else is on the inside. So the numbers are gone, so I could write a 1, but since I have the x's, I'm going to go ahead and write x squared. And don't forget, this had an index of 3, so we got to put the 3 back there. All right, now let's do 64. Start with 2. 2 goes into 64 32 times. 2 goes into 32 16 times. Just keep dividing by 2. Until we end up with the 1s. I have 1, 2, 3, 4, 5, 6 2s. So I'm going to write those here. Now I have x to the 8th, so I'm going to write 8 of them. And I only have 2 y's. So I'm going to put this all under the radical with an index of 4. So I'm looking for groups of 4 now. So 1, 2, 3, 4. As soon as I circle it, I put it on the outside. 1, 2, 3, 4. And then here I have 4 more x's, so I'll circle it again. And every time I circle something, I write it once on the outside. And then I don't have enough y's. So on the inside, I have 2 times 2, which is going to be 4. I don't have any x's left, but I have 2 y's, so that's going to be y squared with an index of 4. Now here we can simplify that and get 2x squared to the 4th root of 4y squared. All right, now we're going to look at powers of I. And so before we do that, we got to start with what we know about i's. And so if we have I to the power of 1, it's just I. I squared is going to be -1. I to the third is really just I squared times I, and so we just said that I squared is -1 times I, and so this is just -I. And then I to the fourth would be I squared times I squared, which is -1 times -1, which gives us a +1. And so a way you can memorize this is by remembering, or to remember that I1, 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 with the middles being negative. I don't know, maybe that'll help. All right, so I to the 9th, I'm going to actually just break it down to I to the 4th times I to the 4th times I to the 1st, because I to the 4th is just 1. I to the 4th is just 1, and so 1 times 1 times I is just I. So I to the 9th becomes I. And so we can always break it down like that, or we learn that if we take that exponent, so let's look at the 30, and we divide by 4. So how many times does 40 go into 30? So it goes in 7 times. And so now you have to do the division because we want the remainder. And so my remainder is equal to 2. Well, that remainder will coincide with the exponent. So I to the 30th would reduce to I to the 2nd, and I to the 2nd is equal to -1. So this here would be -1. Let's try the I to the 23rd. Same thing, I'm just going to take 23, divide by 4. So 4 goes in 5 times. I get a remainder of 3, so that remainder becomes my new exponent. And then we look at our pattern. I to the 3rd is just equal to -I. And I to the 144th, take that 144, divide by 4. Not 4, 6. 6 times 4 is 24. And so when we get a remainder of 0, remember, anything with the remainder of 0 is 1. So if 4 divides into that evenly, it's always going to be 1. If it's divisible by 4, it's always 1. Or you can remember that I to the 0 is 1. So now we're going to look at some complex numbers where we're adding. And so when we add this, we're just going to combine our like terms. So it's going to be 4 plus -2. And then 2i plus -5i. So 4 plus -2 is just going to become 2. 2i plus -5i is -3i. And it has to stay in that complex number form where it's a plus bi, the real number plus the imaginary. And so we look at the second one here. Now we notice we have a subtraction. So when we have that subtraction, you can either think of it as distributing a -1 or leave change. So I'm just going to rewrite this as 4 plus 2i. So a negative gives us a +2. A negative negative gives us a positive 5i. And now I combine my like terms. 4 plus 2 is going to give me 6. And then 2i plus 5i is going to give us 7i. So the first one was addition, the second one was subtraction, and now we have nothing in between the parentheses, so now here, that means we're going to multiply. So we're going to multiply the numbers first, so the negative 6 and 2 gives us negative 12. And then I squared times I squared is I to the fourth, and what we just talked about before, when it's divisible by 4, I to the fourth is just 1, so negative 12 times 1 is negative 12. Another thing you could have done here is, if you remember that I squared is negative 1, so that would have turned that into a positive 6. Here, I squared is negative 1, so that would have turned that into a negative 2, and so 6 times negative 2 still gives us that negative 12. Alright, here, so we're just going to distribute this. So negative 5 times 4 gives us negative 20. And then we have a negative times a negative, which gives us a positive. And 5 times 6 gives us 30i. Next one, same thing, we're going to distribute. So this one has an I, so 3i times 4 gives us 12i. And then when we distribute this, positive times a negative gives us a negative. 3 times 2 is 6. And I times I is I squared. But that I squared is going to turn into negative 1. And so that's going to become 12i. And treat this as a negative. Negative negative is going to become positive 6. And then we got to write it with the real number first. So 12 plus, or 6 plus 12i. Alright, the next one, we have a binomial times a binomial. So you could FOIL this. I'm going to do the box method just to review that. So let's do 3 minus 2i on top, 4 plus 5i on the left side. Now just multiply. So 3 times 4 gives us 12. 4 times negative 2 gives us negative 8i. 3 times 5i gives us positive 15i. And 5 times negative 2 gives us negative 10. I times I squared. But remember, since we have that I squared, this becomes negative 1. So this negative and this negative is going to turn into a positive 10. Now we combine our like terms. So 12 plus 10 is 22, and 15 minus 8 gives us a positive 7i. Alright, so now we're going to work with the conjugates. Now, when we have a monomial on the bottom, we don't need to multiply by positive 11i. You can, you'll get the correct answer, you just have to reduce. If I just multiply by I, that'll still give me the correct answer. So I get 6i on top, and on the bottom I get 11i squared. The I squared is what we wanted because it gets rid of the I, and so now a negative and a negative is going to turn into a positive, and so this becomes 6i over 11. So again, since the monomial you could multiply by I, I'll multiply by negative 3i just to show you that it still works. What's going to end up happening is I'm just going to have an extra step. Alright, so on top, that's going to give us negative 6i, because we're distributing, positive 6i squared. On the bottom, 3 times 3 is going to give us a negative 9i squared. So now I got to take care of those I squareds. That's a negative 1, negative 1. So this is now negative 6. So let's go ahead and rewrite it with that coming first. is that negative and positive became negative 6, and I put it first. On the bottom, that negative negative is positive. And so now what happens here is they have, since I multiplied by this 3, everything is 3 times greater, so I can actually factor out a 3 on top. And get negative 2 minus 2i, and then on the bottom, 3 times 3, so these cancel. And so my final answer is just negative 2 minus 2i over 3. And I would have got the same thing here had I multiplied by just I. So multiplying by I is actually better. That would have gave us 2i minus 2i squared over 3i squared, negative 1, negative 1. So you can see that gives us 2 plus 2i over negative 3. And so here the 3 negatives on the bottom, here the negatives on top, but they're both the same. Alright, so now we have a binomial on the bottom, and so now that's going to require us to multiply by the conjugate. So the conjugate of 2 minus 4i is going to be 2 plus 4i. So the first step is just writing it. And so what happens now is I'm going to do the box method for the top and the bottom. Do the box method twice. So this is 5i, 2 plus 4i. And then for the bottom, two minus 4i, 2 plus 4i. Alright, so over here I get 10 plus 2i plus 20i plus 4i squared. Remember that I squared is going to become negative 1, and so 4 times negative 1 is going to be negative 4. So on top, that's going to become 10 minus 4 is 6, and then 20i plus 2i is 22i. And then on the bottom, so 2 times 2 is 4, minus 8i plus 8i minus 16i squared. I squared becomes negative 1. The negative 1, negative 16 turns into a positive 16. And so now on the bottom, we're going to get 4 plus 16 is 20. And what happens here is the 8 and the minus 8 cancel out. So now, since they're all even, I could reduce by 2. So the 2's cancel. And so I'm left with 3 plus 11i over 10. Okay, so we're going to multiply some binomials. Since I've already practiced the box method a couple times, here I'm just going to practice FOIL. And so the F stands for the first term, so x times x gives us x squared. Typically when you FOIL, you actually draw the arrows each and every time. So the x times x gives us x squared. Now the O is the outer, and so the x times the 9 gives us 9x. The I stands for inner. Maybe I should write over it in that color so you can see. Okay, so now 3 times the inner numbers. 3 times x is 3x. And finally the L stands for last, so 3 times 9 is 27. Combine your middle terms, x squared plus 12x plus 27. So that's how you would typically do FOIL. The way I taught you to do it is to try to increase the speed. So x times x is x squared. And then the OI would be the one I'd let you write. So the outer So that gives us negative 4x. The inner, negative 1x. So negative 4 and negative 1 make negative 5x. And then the last, negative 1 times negative 4 is positive 4. Again, if you're not comfortable with this, you can always go back to the box method. So we'll do the box method just as review. X plus 5. The box method is actually kind of nice because it always works. Very rarely does a student who does the box method get it wrong. So x times x is x squared, 5 times x is 5x, x times negative 2 is negative 2x, and negative 2 times 5 is negative 10. Combine your like terms, x squared, so now negative 2 and 5 make positive 3x minus 10. Alright, just some more multiplying. So these are great ones to do the box method on. Do the box method one more time, then I'll go back to FOIL. So 2x plus 1, make sure you include the sign, 3x minus 4. And so 2x times 3x is going to give us 6x squared plus 3x, because 3x times 1. 2x times negative 4 is negative 8x. 1 times negative 4 is negative 4. Now we rewrite it, 6x squared. Combine your like terms. Alright, so for the next one, since that we have that squared, it just means we have two of these. So 5x minus 4 times 5x minus 4. And now let's go back and FOIL. So 5x times 5x is 25x squared. Now the OI, 5 times negative 4 is negative 20x. Negative 4 times 5 is negative 20x. And so the signs are the same, so we're going to add them up, keep the sign, so minus 40x. And then negative 4 times negative 4 is positive 16. Alright, next one, 2x times 2x is 4x squared. The OI, here we get negative 2x. Now we get positive 2x, and so they're opposites, so they go away. And now the L, the last, 1 times negative 1 is negative 1. Alright, so now we're going to factor. Remember, factor just means write as a multiplication problem. These are actually some of the most missed ones because we always forget, whenever we factor, we always start with the GCF. Do they have a common factor? So does some number go into 2, 8, and 14? Well, since they're all even, that means I can take a 2 out and get x squared plus 4x plus 7. And here you would keep going to see, could it factor? You'd want to keep going here and see, could I get something that multiplies together to give us 7 but add to 4? But since 7 is prime, it's either 1 or 7, and that won't make 4. So that's our answer there. Here, this has 2 x's and 1 y. This one has 1x and 2 y's. So if I'm going to factor it out, if they have it in common, I can circle it. So I circled 1x, so I can take an x out. I circled 1 y, so I can take a y out. And so wherever I circled, like in the birthday cake method, goes out. Whatever didn't get circled stays in. So this would be x minus y. So x times x is x squared. Y times, there's only one y. Y times y would be xy squared. Okay, so now here, let's start with the number. If the smaller number goes in the bigger number, that means you can factor it out. Here this has 2 x's, here this has 1x, so I can, they share it, they have it in common. I'd be left with 1x, and then 20 divided by 5 would give us 4. So whenever you're factoring, you can always check it. 5x times x is 5x squared. 5x times minus 4 would be minus 20x. So when you multiply it out, you should get your question. The key, though, is if you do that, remember that this is the answer. Every once in a while, I'll get a student who does all the work and then checks it and then writes down their check as the answer. All right, so we're going to try reverse FOIL here in this one. So we start with the open parentheses. We know the first term is going to be x squared, so it has to be x times x. Now, since this is a positive and the last number is a positive, that means that the middle signs, or the signs, have to be positive. So now we've got to think what numbers are going to multiply to 28. There's a lot of them. There's 1 and 28. There's 2 and 14. And there is 4 and 7. And so as we look at these, we want to find which numbers are going to add to 11. And so that would be 4 and 7. Now for this one, we can do reverse FOIL again. What's nice about 5 is that it's prime, so we know it's going to be 5x and x. But now, because this is negative, that means this could be positive, negative, or negative, positive. So it's a little bit more work. And so now you just kind of got to guess and check. So since that's a 4, I'm going to go ahead and guess this is a 2 and this is a 2. And so now I got to check my signs. So let's do minus, plus. And so remember, FOIL, my first 5x times x is 5x squared. My last negative 2 times 2 is negative 4. It's the oi, that's the hard part. So 5 times 2 is positive 10x. I already know this isn't going to work because of that positive 10x. Minus 2x gives me a positive 8x. I need that to be a negative. So if I switch these signs, now 5x times negative 2 is negative 10, and 2 times x is a positive 2. Negative 10 and 2 gives us that negative 8. And so this would be my answer. But that's guessing and checking. So instead of guessing and checking, we do have a way that always works, and that's called the Xbox method. And to do the Xbox method, we start by writing AC on top. So 3 times 10 is 30. And the B on bottom, which is 17. And so we play the game of what numbers are going to multiply to 30 and add to 17. So you think about it and you end up with 15 times 2 is 30, 15 plus 2 is 17. Now just as a reminder, 3 times positive 10 is positive 30, and this was a positive 17, so you still have to pay attention to the signs. So that's the X part. Now we do the box of the X box. So the first number goes in the first box. The last number goes in the last box. And your answers go in the remaining boxes. So this becomes 3x squared, the first number. Our last number was positive 10. And then positive 15. Now the key here is you got to remember to put the x. And here, positive 2x. And then we're going to take out what they have in common. So can the small number go in the big number? So I can take out a 3. And then this has 2 x's. So we can kind of do what we just practiced. If they share an x, we can write it on the outside. Here, can the small number go into the big number? So 2 can go into 10, so I can take out a 2. This has 1x, this doesn't have 1, so they don't share anything. Now here, 3 and 2, no common factor. Here, same thing, x squared and x. So they share an x, so I can put an x here. And then what's the smallest number that goes into 10 and 15? 5. I shouldn't say smallest number. What's the greatest common factor? What's the biggest number that goes into both of those? So that'd be 5. And this has 1x, this has 1x, and this one doesn't have an x, so they don't share an x. And so I think the answer here is going to be 3x plus 2 times x plus 5. And again, I would just quickly check this. 3x and x is 3x squared. 2 times 5 is 10. Now you check the OI. 3 times 5 is 15. 2 gives us 2x, so 15 and 2x gives us 17x, so that is the answer. Okay, so just as a practice, I'm going to stick with the Xbox method because it always works. So the number that goes on top is going to be a times c, so negative 36, positive 5. So what number is multiplied at negative 36 but add to 5? So 9 times 4 is 36, but it has to be negative. And then negative 9 plus 4 would give us negative 5. So let's change these signs. 9 minus 4 is 5. Now let's go to the box. First number goes in the first box. Last number goes in the last box. Notice you put the sign. And then my answers go in the remaining boxes with an X. So the small number can go into the big number. So I can take out as 3. They both have X's. So now when we're looking at this, they both have negative, so it means we're going to take out a negative, and 4 goes into 12, so that's going to be my common factor. 3 can't go into 4, but they both have an X. And then the greatest common factor that goes in the 9 and 12 is going to be a positive 3. So I think my answer is 3x minus 4, x plus 3, and then you could quickly check that and it looks like it works. Right here, remember, this is a special one. 25x squared is a perfect squared. 1 is a perfect squared. And so this is what we call difference of squares. And so we just square root the 25. We square root the 1. And we write it with different signs. Same thing here. This is difference of squares. So we get 9x plus 3y, 9x minus 3y. But now you might notice something. If I go 9x times 9x, that would give me 9x squared. And this needs to be to the 4th power. So here I have to put the 2. Because when I add the exponents, 2 plus 2 will give me that 4. So here, if you don't see the pattern, you can always go to the X box. When numbers multiply to 25 but add to 10, that would be 5 and 5. Draw your box. So 25x squared plus 1, 5x and 5x. So 5 goes into both of them. They both have x's. Here they don't have anything in common, so I gotta take out something, so I take out a 1. Here, 5x, same thing, a 1. And so this is just 5x plus 1 times 5x plus 1. Now you may have noticed that since this is a perfect square and this is a perfect square, you could have got to this a little bit quicker. And so that's what I notice over here. 64 and 9 are both perfect squares. And so this is going to be 8x with 3, 8x and a 3. Now this was a positive, but the middle is negative. And so if They both have to be negative because a negative 3 times negative 3 gives us that positive 9. All right, so over here, this last one, you remember, always start with the GCF. I haven't said that enough because none of those had GCFs, but this one does. So you can take a 7 out and have x squared plus 4x plus 4. And then you got to see, can I keep going? And as you keep going, you got to make sure you bring that 7 down. And so what numbers are going to multiply to 4 but add to 4? That would be 2 and 2. Okay, so now we're going to factor by grouping. First thing is make sure it's in standard form, so it goes 3, 2, 1, none. Once it's in standard form, you can cut it in half. And here we have 5x cubed minus 15x squared minus 9x minus 27. And so 5 goes into both of them, so you can take a 5 out. This one has 3 x's. This one has 2 x's. So that means I can take out 2 x's. And so I'd have x squared. And so I'd be left with an x here. And then what times 5 gives us 15, so that'd be minus 3. Now notice here how this has both negatives. So I'm going to take out a negative. So take out a negative 9, because 9 goes into both of them. And so that would be x. Okay, hold on, that would be a positive 9x. So I take out a positive 9, and so that gives me x minus 3. So I knew something wasn't working because these weren't going to be the same, and so I had my sign wrong there. Alright, so these have to be the same, which they are. So when they're the same, all you do is you rewrite it by putting these together. 5x squared plus 9, and then x minus 3. You only write this one once. Right here, be careful when I cut this one in half. Alright, so let me just rewrite it here. 20x cubed plus 15x squared minus 8x minus 6. Okay, so what do 20 and 15 have in common? Looks like 5 can go into both of them. This one has 3 x's. This one has 2, so I can take out 2 x's. And so here I'd be left with 4x, because 4x times 5x squared is 20x cubed. And then I'm taking a 5x squared out of 15. That's going to give me 3. Now they're both negative, so that means I'm going to take a negative out, and what number goes into both of them? And so that would give me 4x plus 3. These are the same, so that means we did it right. You put it together, 5x squared minus 2 times 4x plus 3. Alright, our last one here. Now notice it goes 3, 2, 4, 5, so that's not in standard form, so we're going to rewrite it. T to the 5th plus t to the 4th plus 4t cubed plus 4t squared. Cut in half. So this one has 4 t's, this one has 5, so I can take out 4 of them. So this is t plus 1. Here I can take out a 4, t squared, and this will leave me with t plus 1. So now as we put that together, this is t to the 4th plus 4t squared, t plus 1. So I put this and this together here. The t plus 1 we wrote once. And now here, if you remember in IXL, we couldn't put this answer in because this isn't completely factored. This has 4 t's, this has 2, so they actually share that. And so I can actually take a t squared out of that one. And so that's why this becomes t squared plus 4. All right, so for the sum and difference of cubes, you got to remember the formula. And so the formula is a cubed plus b cubed equals a plus b. The first signs are the same. The second signs are different. So what cubed gives us x cubed, so just be x. What cubed gives us 8. So that means wherever there's an a, I'm going to write an x. So an x is going to go here, here, and here. So x squared wherever there's a b, I'm going to write a 2. So it's plus 2 times 2 plus 2 squared. So now we can clean that up a little bit. So x plus 2, x squared minus 2x plus 4. And you can actually do a quick check. X times x squared gives us x cubed. Positive 2 times positive 4 gives us a positive 8. All right, now the formula for with a minus. So let's see here, a cubed minus b cubed. Remember, the first sign is the same. The second sign is different. So same thing. What cubed is going to give us 27x cubed? So that's going to be 3x. And what cubed is going to give us 64? So wherever there's a, I'm going to put a 3x. So I got to put a 3x here, a 3x here, and a 3x there. Now this is going to be squared. Now let's take care of the b. Wherever there's a b, now I'm going to write a 4. 4 goes there, there, and there. So it's AB, so I have to go times 4 here, and then plus 4 squared. So now let's clean it up, and I'll write it down here. So 3x minus 4, and 3x squared is 9x squared. 3 times 4 is going to give us positive 12x. And 4 squared is going to give us 16. Again, you could do a quick check. 3x times 9x squared is 27x cubed. Negative 4 times positive 16 is negative 64. And that's just a quick check. That does not guarantee you get it right. So now on these ones, you'll notice that nothing cubed is going to give me 5, or no whole number cubed is going to give me 5. And so whenever we factor, we always start with our GCF. So I can actually take a 5 out of that and get t cubed 8u cubed. So now the pattern's the same. A cubed plus b cubed. First sign's the same. Second one's different. And so what cubed gives us t cubed? Going to be t. And then what cubed gives us 8u cubed? So wherever there's an a, I'm going to write a t. it's going to be t squared minus t. And wherever there's a b, I'm going to write 2u. Clean it up. So t plus 2u, t squared minus 2tu plus 4u squared. And unfortunately, if you do all this work and you write this as your answer, you're incorrect because we forgot to write the 5. So that 5 still has to go in front. Because when I multiply this thing out, it has to equal that 5t cubed. So that's why that 5 needs to be there. All right, let's do this one down here. 192 x to the 4th minus 81x. All right, so in order to use our cubes, we're going to have cubes, and x to the 4th isn't going to be cubed. And so if you're not sure about 192, you can actually do the cube root of 192 on your calculator, and you'll notice that it's not a perfect cube. And so you want to look at 192 and 81 and see what they have in common. And so I can actually take a 3x out of that. And so that's going to give us 64x cubed minus 27. So now my formula, a cubed minus b cubed becomes a minus b. The first signs are the same. Second signs are different. So 4x cubed gives us 64. 3 cubed is going to give us 27. Same thing like we've been practicing. The 4x is going to go where the a is. And the 3 is going to go where the b is. And I'm not going to forget about this. Alright, so we have 4x minus 3. So that's going to be 4x squared. So that's going to give us 16x squared. And then a times b, so 4x times 3. So 4x times 3 is going to give us 12x plus 9. With the 3x in front. So this factors to this.